So originally I thought to talk about mock, but I figured, you guys, this stuff is talked about in the book. There's a lot of really interesting papers about it, and so it's something that you could probably find out on your own and read up on. So instead, I thought, why not talk about something that has both relevance to me because I'm working on it, so I know a lot of the details, but also has relevance to what you're going to be studying next month. And is something that that is, I think, is a very fun type of service out there. So what I want to go through is just tell you, what's the architecture like, what are the what are the bottlenecks, how do we manage them, and so overall give you a sense of what's going on in this site. So the first thing that I want to point out is that Photo.net, it isn't huge. It isn't a Yahoo or Amazon or anything like that. But it is reasonably big. It's an online community for amateur and professional photographers. Any of you who have dealt with the ACS know that this means things like B-boards, chat, user ratings, photo critique, just a bunch of different ways for people to collaborate. And all these collaborations are database backed. We have 90,000 registered users. The site has been around since about 93, 94. The number here has actually doubled since about June. We get about 700,000 unique visitors per month. If you're thinking about websites, one of the measures that people measure it these days is by uniques per month. And we get about 8 million page views per month. Now, people also measure, when they think about your website, page views and not hits. If you remember before, people used to initially say, how many hits does your site get? Now we do it by page views. Does anyone know the difference between a hit and a page view? Yes.
A hit simply refers to any file. A page could have many graphics or other types of files embedded, so one page view could be potentially 10 hits.
Yes. So a hit is any time you get an HTTP request. And you can get an HTTP request for a graphic file that is on your page. So if you have you can have a graphic here, that could be one hit. You have a picture, that's another hit. You have another one here, that's another hit. You have the text is usually all one hit. But each page can have lots of different things that are considered hits. Anytime there's a reference to something else that you have to go back to the server to get, that's considered another hit on the server. So you can see why very quickly people started measuring page views instead of hits. The primary reason is that you can throw as many little invisible graphics on this as you want and make it seem like you're getting a horrendous number of hits. But the problem is that doesn't translate into anything commercial, because if you're putting a banner ad up here, this page view, for each page view, you can do one impression, one banner. And no matter how many hits are on here, you can do one or two, however many you do, it's per page, not per hit. So when people start telling you, my site gets mumble number of hits, it's, they're probably trying to either pull one over on you, or they haven't graduated from a couple of years ago when people were measuring it in hits. We get about 3 page views per second, and the peak, that's the average. The peak can actually be several times that. And our bandwidth usage is about 2.5 megabits per second, but we can peak out, especially if we're being spidered by Google or Yahoo or any type of search engine. Now, one thing just as background to this, Photo.net has been around since about 93, 94. Philip had actually started it as a way to talk about photography, and then he started talking about his own personal stuff, his own stories, then he started talking about SQL and Tickle. And about June of this last year, the group of us who are working on it took out all that other stuff that was non-photography related and just kept the photography piece and started adding a bunch of features and optimizing. Since that point, it's grown about a factor of 10. So part of what I'm going to be talking about is how you manage scaling when you're trying to try to go by a factor of 10 and try to manage that going forward. So what does the overall architecture look like? Well, we have the Ars Digita community system, and it's version 3.2 with a hybrid of 3.3 beta. And then we have underneath that, it's running on AOL server. and Oracle. That's all running on on Sun OS, which is running on a Sun E450. And that Sun E450 on it has, it's connected to the network through a 10 megabit per second line, which bursts up to 100 megabit per second. And it's also connected to the storage network's fiber optic channel storage subsystem. So this thing goes out. This thing is the box is running all of this, and the line goes out to the real world. This connects within. This is all hosted at Exodus. Within Exodus, they have, which is a ISP that hosts machines. They have locations all over the world. They have these storage networks, which does basically will sell you disk space that's backed up and managed. Has huge arrays, monster arrays of all sorts of RAIDs. So they have tons of RAIDs. They have their business is based on economies of scale, so they have ways of backing up all of these. You can have them configured depending upon your needs. So you can say, I want throughput, or I want fault tolerance. You guys saw the RAID stuff. And they're connected through a fiber optic channel, which I heard actually has about 3 or 4 times the performance of the local drives. So this is sweet. We do have some local drives, as we'll see more, but this kind of outsourcing of storage is something that, if you need the speed and you don't want to pay for all of these disks and maintenance, this is a better way to do it. Now on the other side here, this and other machines are hooked up to an Ars Digita F5. And what this is a intelligent router, configurable router. So it can do things like traffic shaping, which we talked about yesterday. It can limit the amount of bandwidth that comes in from any one of these channels, so it can make sure that you can control that. It does monitoring to make sure that your site is up and will warn you if it's not. There's just a ton of things you can do with this F5. Now the funny thing about this is F5 is from what I hear BSD. It's just a BSD kernel that's got all this cool stuff layered on top of it. And so these hackers went around and made the first version of this, and now you pay a ton of money for this, which is just a regular nice high-end machine with this software on it. But this actually is really nice, and we'll see why in a second. Any questions on this so far? Yes?
If you wouldn't mind going through what each of those layers contributes to the overall.
Yep, that's the next several slides. Before I do that, I want to just talk about scaling, because this is going to pervade when I talk about each layer. When you think about scaling, especially in 1 or more orders of magnitude, the way I like to approach it is to know your bottlenecks. And bottlenecks in a system are what's limiting its performance. So typically you have some type of performance metrics. And these are the ones that you're measuring different aspects that you think are important about the machine's performance. And when one of these starts, as your traffic goes up, you would really like these to go up with the same type of curve. So if you have 10 times as many, well, it depends on the performance metric. For example, if you have 10 times as many users, right, you'd actually like the system to be able to handle that 10 times as many page views in the same way that it used to before. And I'll get into what some of these performance metrics are for each layer. But what you really want to understand is, for these performance metrics, what are the bottlenecks? So remember some of the bottlenecks we've talked about before. One of them is transactions per second. So your database can be a bottleneck. Another one is how many hits, or what's the output bandwidth? How much can you output? That's sometimes a bottleneck. Another one could be CPU usage. These are kinds of bottlenecks that you have to keep track of, and when you scale, if you don't understand your bottlenecks, what's going to happen is at some point as your traffic goes up, the system's going to start acting strange, and you're going to have no idea what's going on and why it does that. So I'll be talking about bottlenecks as we go through. Next thing is that I like doing is anticipating your peaks. So traffic on Photo.net tends to go like this, and then on the weekends it's maybe a little bit lower. But generally, I mean, the peaks are very different than the average. And you have to anticipate when they're going to happen, how big they're going to be, so that you can gracefully deal with them.
Was it like peak every day?
Every day,
What
yeah.
time does it peak?
It peaks between, starts around 11, peaks around 2, and then comes down around 4 or 5. It has a little peak around around that time between 5 and 6, like it just comes down. So this is really actually, it comes down and has like this, and then it comes down. So it's, I mean, you can argue from that the people are really coming from the U.S. more often than not, and our web logs confirm that. So some of the plans you have to have in place is how are you going to deal with peaks? And there are manual ways and there are automatic ways that you can deal with peaks. So one of them is to limit if you understand what the bottlenecks are, is to limit some of the services that cause these bottlenecks to come up. So one of them, for example, for quite a while we had site-wide search on our site was really slow and CPU intensive, and it just ate up a lot of resources. So at times when we would have high peaks, we would actually turn it off for a little while, and then immediately our load would come back down and our performance would be back. I actually fixed all of that about a few weeks ago, and now it's blazingly fast. But this is the kind of thing that if you have, for example, if you're taking too many hits, and that's bogging down your server, you may want to actually drop some of the hits, drop some of those hits, or drop the graphics, or drop something that you think is not as relevant to your site, and that'll help improve performance. But the main thing is, and as we go through these, I'll show you how we can deal with peaks at each layer. These are things that you end up, you'll have some idea when people tell you what they are for their system, but you're going to end up having to figure out what these bottlenecks are for your system and how best to manage your own peaks. And so the first two here are very tactical. So they're just sort of, short term. What do I do? What do I do now? If something happens, what do I do in the short term? The big thing is you have to plan ahead. If you think that in 6 months you're going to have another order of magnitude increase in your traffic, you have to examine your bottlenecks and say, how do I manage that increase given that I have these bottlenecks? What do I need to do? Do I need to reprogram things? Do I need to buy more hardware? Do I need to buy more bandwidth? You have to plan ahead, because once it hits you, and at some point you're going to have, in the real world, there's delays between how soon you want something and how soon you get it. So following up on that, for us, we actually have quite a few ways of measuring what we consider our performance. And this is a great way to measure whether there's bottlenecks that are affecting the system. One mistake that a lot of folks make is they think, oh, as long as my machine's humming and running and doing well, then everything is good. And what they don't realize is that the extent to which people are going to want to use your site or come back to it really depends on how things look on their end. Give you an example. One of the big mistakes we made when we first relaunched the site back in June was we changed the page from this straight HTML, like just loads in a flash, looks ugly as all heck, it's hard to navigate. We changed that to this nice, different table-based thing where you had little tables here and pictures and all that stuff. Well, the first complaint we got immediately was, this thing is too slow. And we said, well, what do you mean it's too slow? We looked at our server, it looked like everything was running fine. They're like, this is too slow, this is horrible, and people were complaining left and right. We got into this bug, which we didn't measure the end-to-end performance. When we actually started measuring, that we found two huge bottlenecks on their side. One of them was their computers were having trouble displaying these tables very quickly. So this is one of the things in HTML, when you set up a table, it usually waits, the renderer will usually wait until it's got all this table information, and then show you the table. So what was happening was on our site, whereas before it would just start showing the text immediately after it was getting it, it was waiting for everything to get there and then showing it all at once. And we found that people don't like that. They hate that. So what we did as a compromise is we split the page up into two pieces. The top half of it loads very fast. You can notice this if you're on a modem. The top half will load quite fast, and then the bottom half takes a little bit longer to load. And there's like this is where some of the pictures are. And so immediately you get some response. Well, this was great. People loved that all of a sudden it felt like they were getting something sooner, even though overall in time they were getting, they had to wait the same amount of time to get everything. Second interesting example around that is a third-party firm that will measure. It has it's like Akamai. It has all these servers all around, measurement points all around the internet. And what they do is they measure how long it takes. They do a lot of measurements on your website. So how long it takes to receive the first byte of your page. So it'll go out and request the page, and it'll track that, and then it'll say how long does it take to receive the whole page, and it'll break that down between receiving the original hit and then all of the pictures. So one of the things we found was that the time to first byte was too long, and so it took several seconds for them to even get one byte from our server. So we went off and we figured out, we talked to Ars Digit, and we got it squared away with their sysadmins. The second thing we noticed was that our page length was too long, something like 50K. It's like, this is way too much. So we went in, and part of the reason that it was that long was when the person who designed the page, when they were designing it, they had all these great little comments all over the place in white space, just like sitting there, because that makes it easier for them to edit. So we just cleaned all that up, and that just by itself cut the page size in half, and then some more optimizations cut it down even further. So now we had our original, we had it down to something like 10K. So now we had 10K, we had a faster time to first byte, we had this part load very quickly. All of a sudden, things were great. None of this had anything to do with our server humming and being overloaded or anything like that. Keynote, by the way, one of the cool things is you can go there and it's a free for a single use, so you can go and type in any server that you want, and it'll give you these interesting stats on it. So if you have a personal server at home, this is a great way to see what kind of performance other people are getting from that site. WebTrends is a software package that takes your logs, which is everything. It logs all the hits that go on against your web server, and it crunches them into a format that tells you some interesting statistics. So it tells you all the boring stuff, like how many page views did you have, how long were visitors on your site, and in our case it's something like 11.5 minutes per session. But it also tells you other really cool things, like what paths did people take through your site. And the reason that's interesting is because if people start taking a certain path and they all start exiting on a certain page, then there's probably something wrong with that page. And again, it's nothing to do with your server, with your system performance, but overall, holistically, that's one way to monitor whether something's going on. Maybe it actually is something wrong with the page. This is, if you want to go in and look, it might be. Maybe there's some error that some people are getting, but you're not because they're using a different browser. But this is one way to start finding where those choke points are.
They give you the path for each person that comes to the site?
They aggregate it.
How do they do that?
They do one of these algorithms where they have this, they
That shows you like a common path to the site?
Yeah, so they say here's the most common path through the site. So they'll take and they can do that by IP address. So they'll say, okay, this IP address came in, and first it went here, then it went here, then it went here, right? And then this one went from here to here, and then they just have some list where they sort all of that. And the thing is, I know that this algorithm they're using really is bad, because this is a feature that you can turn on or specify for only certain pieces, but if you turn it on for the whole thing, it just takes forever to crunch the log. And even if you turn it on for a little bit, it still takes a while. So I don't know if they're just using the wrong algorithm, or if they're just their programmers are incompetent, or whether it's just an NP complete type problem. But it's slow, and I don't like it. Super Monitor. We have a way of checking on our site exactly which pages are being served at any one time. And we know which pages are being queued up, which means that which pages are taking longer than 1 second, 5 seconds. We can set that that amount. So here's another way to test the bottlenecks. If too many pages are being queued up, then that's bad. These pages should be served very quickly. Super watchdog, the watchdog function is something that looks for errors. So whenever the server gives an error, and that can include something like the scripts being broken, you'll get a lot in this log. You'll get some notice saying, here's the error that happened. Here's some information. And Super Watchdog, when you click on that, it gives you a set of all those errors that have happened for the last several hours.
Are these Super Monitor and Super Watchdog outside third-party software?
These are actually on Photo.net. These are services on Photo.net. Yeah, so those are not third-party. The bandwidth here is sort of a third-party monitor. That one is Ars Digita through the F5 is able to monitor how much bandwidth you're currently using, and so you can click and see what your graphs look like. Obviously, that's one of the things they want to keep very secure because they don't want confidential information for all their clients. But it's something we like to know so that if we see all of a sudden an unexpected dip, we know that something's wrong. Maybe the database is getting hosed. And the best actually measures are end users. And we don't underestimate the power of that. They're going to tell you when something is working, when something is not, and ways that you can't possibly find because you can't test everything all the time. And they'll come back to you and they'll tell you, and if you listen, they'll keep telling you. And if you ignore them, they'll stop. Yes?
Two things. First of all, the bottlenecks then that you found with Photo.net were more from the user point of view rather than from...
Well, the ones I talked about earlier were from the user point of view. And we'll get into, just starting in the next slide, what they are what bottlenecks were in the system.
Okay. And also with the bandwidth monitor, I didn't catch that. You said they want to keep it secure.
Yeah, so Ars Digita, they want to keep that type of information secure on a per client basis because if you're a client, say you're mumble.com, right. You don't necessarily want especially your competitors, to know what your traffic patterns are like. And you also might not want them to know how much traffic you're getting. Because you might some analyst might come and say, wow, these guys just gave a great briefing, and then they look on the bandwidth and they see that there's nothing there, right? And so things like that, or they all of a sudden see this huge increase in traffic and everyone's going to say, well, maybe there's, mumble.com is selling a lot, maybe I should try to buy their stock. So it's something that companies want to keep very confidential. So if you have a website, it's unlikely that unless you're paying a lot for it, that you'll be able to see the bandwidth usage for it, because it represents a security risk for the company that's providing your hosting. But it is very important to know as your web service becomes more of a business or bigger.
Was WebTrends third party?
WebTrends is third party. So WebTrends is third party. It actually costs an arm and a leg. Keynote is third party. Super Monitor and Super Watchdog run on Photo.net. Bandwidth Monitor runs on the F5, and our end users run on their own.
So WebTrends is really important that they keep that secure as well.
Yeah, that's right. And you can, in fact, WebTrends, the last time I went there, they had a special program. So as an end user, if you have your own website, you can put a little WebTrends logo, and then you can then every so often go back to WebTrends and get this type of information. So it's advertising in return for statistics. And they also can scale that up if you don't want to buy their software package to be on a monthly type service, depending on how many hits you get or how many page views you get. Okay, other questions about the bottlenecks and tools? So let's start talking about the architecture. The Ars Digita community system. Basically, how many of you guys have actually programmed in ACS? Okay, one. Which version did you use?
Whatever it was last summer.
Last summer, so it's probably 3x. It's all in Tickle, and yeah. So this is all ACS is at least the incarnations that Photo.net runs and that was around for the last so many months. The main versions of it have all been a bunch of Tickle scripts. Tickle is a scripting language, which is very easy to learn. It feels a lot like BASIC. It's got procedures. It doesn't have a lot of support for scalability. But typically what you do is you write some page in Tickle. if this equals, go to the database and get this information. If it's this, then write out this HTML. If it's other thing, write out this other piece of HTML. And you just go through and write this. What ACS is a bunch of these Tcl scripts that are organized into modules. So you'll have one module, for example, that's a bulletin board module. And it'll have a bunch of these Tcl scripts that go around that you can use to to start new threads, to reply to existing threads, to administer it to moderate it in the background, and so on. And all of this is on our side is actually under CVS control. So that if we fudge something, we can have at least a more recent backup to go to. Now, the content from the ACS, as you know, is database backed. So unlike a website where you just go and look and read, there's people putting stuff in, feeding stuff back into the server. So they'll put things in like photos. They'll put in things like text. They can even put HTML in their comments. And all of this is stored either in the database, which in our case is Oracle, or on the file system. We typically store the photos in the file system just to reduce the load on our database, and then we store the rest of the stuff in the database. Now, one important point here is that because of this high degree of collaboration in Photo.net, each page that the user comes to has the potential to access do a lot of database hits or go to the database several times. And as we talked about before, databases use transactions, and so the number of transactions per second that you can actually do is can be a bottleneck in the system. Since only one person is familiar with ACS, one of the examples of what ACS does is it'll track which pages you've been to that are articles. And so when you click on a user on Photo.net, you can see which pages they've been to, which articles they've read. So this gives you a sense of how familiar they are with the site and what type of content interested them. And this happens even though the content itself may not be something that you type stuff into. Photo.net, it also turns out, each article does have a set of user comments at the end. And so you can actually go and add a comment at the end. So there's more database hits that you can get from that. So this user activity that's tracked behind the scenes adds more load. And what our bottlenecks are at that layer, there's a couple of them. One is script interpretation. So you guys know the difference between an interpreter and a compiler. Well, guess what? Tcl is an interpreter. And so there's all sorts of stuff that the interpreter has to do each time it runs a script. Read, tokenize, parse, tokenize, check syntax, all that stuff. So unfortunately, that happens each time. The other problem that we have as a bottleneck is, as I alluded to before, is the amount of number of transactions per second. If you write SQL code, which is what Oracle understands, that is just going to start bogging it down. Then if you have a module that's sort of a resource hog, it can bog the whole system down. So one of the things you can do is to write better code. So in Tcl, actually, you can go in there and you can see the ACS code. It's all open. It's open source and free, and so you can go in there, modify it, and if you don't like the way people are doing something, and get rid of some of the extra stuff that's going on. You can use compilation. So there's this thing called which is ADP. It's a way of embedding code within your HTML. And what the AOL server down below will try to actually do a little bit of compilation on that, so you skip some steps. There are some trade-offs there, so we typically end up using mostly Tcl. You can do caching. So this is really important. The caching remember the Oracle database it uses transactions. Transactions can be expensive. So what if there's data that an ACS module knows that it can cache after sucking it out of the database, that it can cache until it's changed somewhere else. So this is great because if you have a long query, you can suck out data. Like you can say, okay, what are the last 30 classifieds that I've put up? Right, that's a database hit and it has to go and grovel around and do a date comparison, a bunch of stuff. So imagine if you're able to pull that out and then cache it and store it. So any other time that a user came, you just immediately had that information available at the ACS or Tcl level. you wouldn't have to hit the database. Well, that's great. So all you have to worry about in that case is cache invalidation. So how do you make sure that when someone adds a new classified that you bump that list? Well, you can embed that in the script itself to say, well, with the script that adds a new classified can say, well, once I've added the new classified and entered that into the database, I'm going to invalidate that cache, so the next time you want to get those 30, it'll say, don't get it from your cache, get it from the database again. So this is, you can have a layer, you can build a layer here that's basically sitting right here that does database caching. That's pretty important. When you think about building bigger systems, you want to cache as much information from the database as you can, and it can make a huge performance improvement in your system.
So do you not have a huge cache? Or?
It can be. We have several megabytes of cache, but we're careful about what we cache. We don't try to cache everything. We try to cache queries that happen most frequently, and that are the ones that take the longer amount of time. So, for example, on our home page, we have the last 5 bboard postings, and we have some like the last n classifieds. We want to minimize the number of database hits that you have to do whenever you get to the home page, because we want the home page to load as fast as possible. So what we do is, if there's nothing in the cache, we'll go out and get those 5, the most recent posts, and we'll cache that until someone posts something else, and that'll just stay cached. And so then we eliminate that hit, we eliminate the other hit, and so to get this first piece of it out, we don't have any, that piece of HTML doesn't have any cache hits, any database hits. It has cache hits instead. And the last thing that you can do here is to try to optimize your queries. So you can go to Oracle and you can ask for some information, but the way that you ask for the information can lead it to do a lot more work than it might need to. When we first, as an example, when we first moved to our new platform, to our new relaunch in June, all of a sudden, we switched it over, and then we saw the server was happy, everything was, and all of a sudden we saw this backup, and using Supermonitor, we saw that one page was getting backed up, and it was the page that would go out and grab one of the bboard postings, and it was just getting backed up and backed up and backed up, and soon the server would just crash, and so we'd have to restart it. And so what we ended up finding out was that there was one query in there where it was trying to scan the whole users table each time it grabbed one of these, when it could only do, instead of doing this search, it could only do it only needed to do an order 1 lookup, because we only wanted to look up one user for that particular query. And as soon as we gave the Oracle query that hint, boom, all of a sudden that bottleneck went away and the server started behaving a lot better. So that's one thing, that when you're writing this tickle, and you'll be you have to have a good understanding of what makes a good Oracle query. Any questions on ACS? Right now, currently, there's ACS 4 is the current generation. There are 2 versions of it. One is a tickle version, and one is written in Java. And the layer that's written in Java doesn't have all the modules that 3x does. In fact, the one that's written ACS 4 that's written in Tickle doesn't have them all either. So that right now they've built that version of it, and the latest I hear is they want to build actually ACS 5, which is going to be the next generation of it. So that's pretty much as far as I can tell you that I definitely know. You could probably ask Tracy that question.
Is it still open source?
It's ACS 4 is open source. I don't know what the plan is for ACS 5. AOL server. Philip went out and got AOL server to be open source, and you can go and download it and compile it and modify it. And this is the server that we use on Photo.net. It's also used on all the Ars Digita installations. It's a full-featured World Wide Web server. It's certainly not as popular as Apache. It's got built-in tickle support. So when you compile AOL server, by default it'll understand tickle types of files and interpret them as tickle scripts. it's multi-threaded. We're actually using AOL Server 3.2. The version 3 of AOL Server overall has much better multi-threading than version 2 did. So in version 2 you had much more of a process feel. Remember how when we talked about processes versus threads? Well, ACS 3, the idea there, one of the big architectural differences was, let's get rid of this bottleneck, which is around internal contention for internal data structures, internal resources, and let's multi-thread it so that you can make it more resilient to that type of bottleneck. In AOL Server, when you first start it up, you have to tell it certain things like what are the maximum number of threads that it can use, what are the maximum number of connections that it can serve out, and what are the maximum number of database handles, or in other words, what's the maximum number of connections that these tickle scripts in parallel can have to the database all at the same time. And so I picked those 3 because tweaking those 3 actually has a dramatic impact on how well AOL Server performs. Now, some of the key bottlenecks that we found here, one is lock contention. So you have things like tickle data structures that interact. The multi-threading is supposed to address that at some level, but I've heard Richard Lee talk about some performance measurements that he's done that makes him think there's still some issues that haven't been addressed there. Server log. Whenever AOL Server gets a hit, there's a log that it writes that hit out to. And maybe it's like 100 bytes of stuff. Well, if you have, as you'll see in the let me see, do I write it down? Yeah. So what we actually, I'll tell you why in a second, why we run multiple instances of AOL Server. If you have multiple instances of AOL Server running, then you have to make sure that you synchronize the writes to that server log. So there's another point where you can have contention. Database handles. If you have, say, 8 or 10 database handles open per AOL server, then you can run out if you don't release a database handle after you're done with it. So that's another point of contention.
What's the database handle?
So database handle, when a AOL server is running, there's a certain number of connections that it can have to Oracle. And that number of connections, for each connection that it can have open, that corresponds to a database handle. And so a database handle allows a tickle script to talk to Oracle through the AOL server. And so if imagine that you're running and then one of your tickle scripts is talking to Oracle for a long time, well then there's one less database handle that's available for anyone else to use. And then say another one starts doing that, and another one starts doing that. As soon as you run out, then all of a sudden the server says, well, I can't talk to Oracle anymore, and bad things start happening. That's why when we had this, remember the story I told you earlier about the server started crashing. What was going on was that the database handle was being held too long because this query was taking too long, and Oracle was sitting there chugging. And so as these kind of backed up, then eventually you ran out of them and caused the server to come down. Some tickle commands, and we found this by experience, are really horrible too, like regex, which goes and searches through data for a particular regular expression. It was really weird because regex would run really fast on small inputs, but as soon as the input got it to something reasonably large, it just sat there and chugged for a while. So we had to get around that by using other types of searching when we needed to do that. And then if you're using ADP files, parsing them can also be a bottleneck. We use very few on Photo.net. If you take HTML, you can embed code within HTML, and ADP refers to the language that you use to embed that code. So think of it like it's like Tickle. You have a language where you can say output this thing here, and it runs off and can call some procedure to generate the code and query the database.
ADP is the name of the language? Yeah,
it's AOL. I forget what it stands for. One thing that we do here to get around these AOL server issues is that we actually run multiple instances of AOL server. So on Photo.net, we actually run 6. So there's 6 AOL servers that are running, all serving pages for Photo.net. Now, why do we do that? Well, one of the reasons is that we want to eliminate some of this lock contention. on the Tickle data structures. So if you're running a whole separate instance of AOL server, then your Tickle scripts running here there's no contention for the data structures in there than the ones over here. Another reason is that it gives us some amount of fault tolerance. And this has actually been quite nice. If this, what this F5 can do is it can figure out which AOL servers are up and which ones are down, or which ones are busy and which ones aren't. So it can try to pass the load over to the AOL servers that aren't very loaded. And if one of them crashes for some reason, then that one, there's 5 other ones that can hold the load up until that one comes back up. If 2 of them, it's going to take all 6 crashing at the same time for Photo.net not to be able to respond to requests because AOL server is down.
Is there any cost by having different AOL servers?
There is a cost. So one of the costs is it takes more memory. And that's, as you'll see later on, that's for us that's a big cost. More CPU, and at a programming level, there's cache consistency. So it makes programming a bit more complicated. So for example, remember how I mentioned you want to cache things from the database? Well, that works great if you're running within one AOL server, because within one AOL server you can say set up this cache line and then invalidate it, and someone else who's running can see the invalidation. But imagine that you're in a totally separate process. So you have 2 AOL servers running, and there's 2 processes. Then what you have, the problem there is that you need to maintain cache consistency between these different processes. So what we end up doing there is using inter-process communication to communicate between all of them. And that's how you keep the caches consistent. That doesn't guarantee that the caches will be consistent perfectly, but it does give you some reasonable measure that you'll get cache consistency.
They each have their own cache? I mean, they're not all referring to one.
That's right, because each AOL server has its own cache. It's a separate process, and it has its own Tickle level cache for caching queries to Oracle.
And theoretically, then all of them should be the same.
That's right. That's right. That's right.
Well, that's not replicated.
That's right. We're not replicating Oracle. Yeah. In fact, that's what's next here. So Oracle, we have one instance of Oracle running, and it's it's a full-featured, robust enterprise class database. I don't know what other words they use in the Oracle literature, but I just picked some that I'm sure are in there. And the way that it connects to our AOL server is that there's a special driver that was written by the Ars Digita folks, and this driver takes there's some Tickle commands that you can run that say go to Oracle and run this query. And what the driver does is it takes that query, and then it connects to Oracle through that database handle, and then runs that query, and then when it gets back, it returns in a way that Tickle can understand it. So if you say something like select from dual is this generic table, that'll go to Oracle. Oracle will run that. It'll return the number 1 as a Tickle, and the driver will make sure that it's in a format that Tickle can understand. So it'll be the number 1 in Tickle, which is a string. And so these things can get pretty complicated, but the driver is in charge of doing that. Now, one of the things that drivers come under a lot of scrutiny, and because based on how that driver is written, you may get into some performance issues between AOL server and Oracle. So for example, this was one of the problems we had with site-wide search. Suppose that you give Oracle a query that says do a site-wide search, and instead of returning me all 2,000 results, I only want 30, the top 30. Well, if this driver is written so that it waits until everything comes in before sending it back, that's going to send back all 2,000, and then you're going to have to cut off the other 30. So one thing and I've talked to the folks who have done this, and so I don't actually know how they end up doing that, and neither do other folks that I've talked to there. But one thing that you can actually do is write procedures over here that compute the thing you're looking for, that can narrow down the search to whatever it is you want, and then that gets sent through this pipe over to AOL server. So that's what I did for site-wide search. It made a huge difference in performance, and I didn't have to worry about whether this driver was going to be, how it handled the data going back and forth. Oracle, as you can imagine, is supposed to support hundreds of simultaneous connections, but it does have bottlenecks. And the main bottleneck that it has is contention over its tables. So this relational database is just a set of tables, and you have some way of keying these tables, and each table has rows and columns. And when you ask for a row, or you can ask for the whole row, or you can ask for certain pieces in a row. You can update rows. You can index them to do searches, but this ends up being the shared resource. So like what we have in Photo.net is one table that's called the users table. In that users table, we keep track of your user ID, we keep track of your name if you gave it to us, we keep track of your home page. So all that is stored in here. Whenever you go to update your user information, it finds the row where yours is stored and it updates that. When you do things like try to figure out whether someone has the right permissions to access one of your photos, it'll go through and access this table to make sure that you're still an active user to begin with. Because if we ban you, we might have banned you because we don't like the photos that you're uploading because they're nasty. And so there's permission checks. This table gets accessed quite often. There's another one called, there's the users. Another one that gets called often is the B-board. People love the B-board. They ask questions. They'll get an answer back within 15 minutes, half an hour. Usually it's a lot less than that for something completely obscure about photography. And so we have this B-board table, which is about around 200,000 rows at this point. And whenever you do a search, some of these B-board rows will come up, and so when you click on that, it goes to the table and it finds that. The other thing about the B-board table is because it's a question and answer type of forum, each row corresponds to a question or an answer. So when you go to get a whole thread, you have to access several pieces of this table to grab that out. So there's a lot of contention at different levels for these tables. There's contention at the database level, which is if you're trying to write something, no one else is going to be able to read that until you've aborted or committed. And there can also be contention at the lower layers, which is if you're trying to access the disk, and the disk is at different points in this file, then you can have the heads having to go back and forth to try to get the data to you that you need. So as in most database-backed systems, our database is one of the things we look at very carefully because the transaction rate that we can get through it can severely limit how much processing, how many requests that we can actually serve. So how can we get around this? Well, remember how we talked about caching at the AOL at the tickle layer. At the ACS layer, the less number of hits that we can have on the database every second, the more availability we'll have as more users come on. The other thing that we can do is use RAIDs or use something like this storage networks, where we try to minimize the lower layer contentions, like the disk contention, for different pieces of the database. Unfortunately for us, adding more CPUs isn't going to improve the situation. Not necessarily, because the contention here is around access to the data, and that the CPU isn't yet the bottleneck to that. So processing the data isn't the bottleneck right now for us. It's getting access to it, so reading and writing it. Why do you think adding more CPUs could slow us down?
More processes get to the point of needing to use a particular piece of data at a time.
That's right. There's more people wanting to use particular pieces of data, and so there's more contention, and that creates it raises the specter of deadlock. Though I think we don't really have that issue. But there's all of a sudden, when there's more contention, things start backing up, and so we can have things back up and cause our server the performance to go downhill. These types of things here, there's some really interesting articles on arsdigita.com. They have a piece of it called the Ars Digita Systems Journal, or ASJ, and they actually go through and will tell you what their tuning hints are for this. Every site ends up being different, but it's a great place to start, and that's where we started when we wanted to tune, and we're in some completely different place than where we started, but it's better to start there than to start just guessing. So what about our hardware? Well, it's an older but reliable server that we have hosted at Exodus. It runs SunOS 5.7, so it's been patched and it's got some security upgrades, all that good stuff. We have 4 gig of RAM, and we have one system drive. Or sorry, disk subsystem is one system drive, so that's where all our operating system is. A bunch of the temp files, swap file, etc. We have 4 local mirror drives, and that's where we put things like our database files on the mirror drives. We put all our photos on the mirror drives. And then we just got 2 of these fiber channel drives connected up to it. And we're really excited about starting to use those because they seem to have a lot better performance than the local mirror drives, which is pretty amazing, actually. I wouldn't have believed it.
Where are they located?
At Exodus.
Is that in state?
Yeah, it's in Waltham. So they have this big facility out there, and there's guards that sit there and like look at you funny when you walk in, and you have to be authorized to walk in there. And the reason is, you can imagine there's a lot of companies that are competing with each other that are all hosted there. So if you're like if you're Google and you happen to see the Yahoo machine, you might give it a big whack, right, or do something to it. So to prevent that, there's security who watches you all the time. And Rajiv, who's been out there on several occasions, tells me that some of these folks, they build actual cages around their space. So you rent out floor. If you're big, what you do is you rent out floor space there, and you do whatever you want with that floor space within their guidelines. And so some folks actually have like some really nice looking, beautiful sort of glass casing and all this stuff because they probably want to bring their clients and show them, like, right. And some people just have these cages that are with wire and locks and everything, and I believe that's what Ars Digita has. But yeah, and then you have a section that's where they do that isn't like that. So there's people who didn't bother to build these things, and so it just kind of looks like this interesting zoo. When I did a study on web hosting before, and I got to understand the economics of this whole place, and it's quite interesting. Because you can put a facility like this out in the middle of nowhere, right, and all you need is good connectivity, you can make them quite big and get a bunch of economies of scale. But the main thing is people aren't going to trust that facility until it's been certified to make sure that things like the power isn't going to go out on you. They expect like perfect power, that the security is going to be okay, that there's not going to be flooding, and people learn the hard way that they have to be careful about this. GTE had a facility that they had where they had everything all set up and all this redundancy, and then it turns out that at some point there was flooding that happened because there's a lot of rain, and that's one element they hadn't considered, and the whole thing went down for a couple days. And after that, I mean, you can imagine customers were livid, and it took a while for them to come back from that. And so now that they know better, but you never know what's gonna hit you. You just have to try to plan ahead. So that's where the E450 is. What happens is this cable here. It's you'll see cables running out of these cages, and this cable is one of them that goes over to where Storage Networks has all of their machines. And the sysadmins say basically these machines are these big honking pieces of hardware that are just full of hard drives, have memory in them, and just they're actually quite a substantial capital investment. So Storage Networks won't take you on unless they're convinced they can buy another one of these things to increase their overall capacity to support you. So that's why they only take big customers, and they charge you by the megabyte. And it's actually pretty expensive. All right, well, so now that we know how all this is set up, the question is, how do we improve the performance of all this? So this is in the plan ahead stage. So we've gone through what some of the bottlenecks were and how to react to them. We can handle the peaks, but how do you make this perform better going forward? One of the things that you can do is move to a 3-tiered architecture. So right now what we have is this F5 that's sitting in front of our E450. And this runs all of the things that we saw before, the AOL server, the Oracle, and so on. Well, one of the things you can do is add another tier here. And what these boxes are here are they're not thin servers, but they're a lot less sort of hunkin servers than this one is. This one has 4 CPUs. It's got 4 gig of RAM. It's maxed out, unfortunately. But these over here, you can imagine them being high-end, Intel-based machines that are running, Linux or some kind of robust Unix type of operating system. And so, what do you do with these here? Well, these here, what you want to do in essence is you want them to offload some of the work that the E450 is doing. And so the kinds of things for Photo.net that would be really helpful to do, one of the great things would be the photos. So we have all these photos. We have thousands and thousands of photos. And serving up one of these photos should be something that the E450 doesn't have to worry about. It should only be worried about the database, like doing something with the database. So imagine if these guys up here had huge amounts of memory so that they could cache a lot. And they were connected to the E450 through something like AFS or NFS. Whenever you started asking for a request, these guys up here, anything that's a photo, would be immediately sucked in, and they would be in the cache. So then when people start asking for those same photos again, you don't even have to go through to storage networks or wherever it might be stored. It's just already there locally. Boom, it's out. You can do that. That in and of itself, I think, for Photo.net would be a huge performance increase. Right now, our E450 is maxed out on RAM, and in fact, we usually tend to use about our working set is around 6 gigabytes. Since we only have 4 gigabytes of actual physical memory, that means that we're swapping. And as we know before, swapping is bad. So by offloading that work onto these 3 servers, we can reduce the memory requirements on the E450. Up here, we can set up these servers by them so that they can take a huge amount of memory, and run up, and we could even run ACS, right, and the AOL servers up here, and just use the E450 for doing the database updates and reads. Now, the nice thing is that when you go to this type of system, these boxes here don't have to be that expensive. I mean, the E450s range from about 60, well, if you have academic discounts, 60, but usually in the range of 100 to 200,000, depending on how it's configured. These over here can cost, $10,000, $15,000 each. So instead of buying lots of these other machines, you just buy some of these that are specialized towards helping out with the work. Now, a lot of times when you hear people talk about their web architecture, they'll say it's a 3-tier architecture, and this is the kind of thing they mean here. Just to go back to the F5, the nice thing about the F5 is that it can understand things like Photo.net is actually 64.16 whatever, and that translates to any one of these being able to serve that address. So it handles all of the load sharing or the load balancing. It knows when one of these machines is down that it can rely on the other 2, and so that work is done transparently for you by the F5. Okay, so that's one of the things.
What trade-off
Yes.
is there a trade-off involved in adding those servers? Now does each request first have to go through one of those before it hits the E450?
That's right. So one of the trade-offs is that the requests now are processed here, and if they need access to the database, they have to link in through the network. So now this can become a potential bottleneck. Is one of the trade-offs.
Is it going to significantly increase latency, or is it only a slight difference?
It will, unless you cache very smartly. So the whole idea is to try to minimize the interaction with this. So what'll happen is that some hits will end up having more latency associated with them than others. Whenever you update, for example, whenever you add another bboard item, and that invalidates some of the caches, the next person who hits will have to take the full latency hit for that, but then people after that won't have to because things will be cached up here. So that's exactly why you want as much physical memory as you can afford, because that caching will help you minimize the amount of latency you have to deal with here.
You couldn't have a connection directly from the F5 to the E450 that knows whenever it's a database request go directly to the E450. You don't even.
Well, the F5, all it does is think of it as a router that just shepherds requests, and it's these guys up here that would have to determine whether or not there's a database hit involved. The other piece of complexity is you have these three running here. Remember how we had the different AOL server processes, and we had to do cache consistency between them? Well, now you would have to do cache consistency between these three. So that actually is probably the worst complication here. Is doing it on the same machine is one thing, but doing it across machines like that can start hurting. Because, consistency, replication like this, the big problem is consistency. Consistency hurts. Yeah.
The images in Photonet are in the database, right?
The images, actually, we store them on the file system.
Okay.
Yeah, we wanted to minimize the database hits. So we just said, let's store them on the file system. AOL server knows how to serve files from the file system fairly well, and so we made the decision to pull them out. When we were talking about with ArZigit they asked us about for advice on their next version of the ACS, and in particular, they have this content management system. And one of the things that we told them was it'd be really nice if you could transparently manage where a piece of data was stored. So whether it be locally or in a database or somewhere else on it could be network storage. But that way, you wouldn't have to explicitly bring that in as part of your code that you write.
Everything else is in the database, all the bulletin board stuff?
Yeah,
files,
right. Right.
HTML layout, page.
The article files are not in the database. So if you have the HTML, like a Phillips article on the buying a tripod or what kind of tripod should you use, that's a page it's actually stored on the file system as HTML. And what happens is when these guys get a hit for that page, or when this one gets a hit for that page in this architecture, it goes in and sucks that HTML file in, and it says, okay, now in the database I have some comments associated with that particular article. So what it does is then it creates HTML that glues these two together and shoots that out. And it also tracks. It also says it tracks which user actually accessed that file and writes something in the database to that effect.
What do you use that for? All the user choices.
Philip had this interesting idea that this is all about, like, you have to help people to do two things. One is to learn on the system, and the other one is to get a feel for how much other people have used the system to gauge how much they've learned from it. So one of the ways that you use that is if you click on a user or on yourself, you can see what you've looked at, and if there's pieces of Photo.net that you haven't looked at. If there's, for you personally, what that helps is that there's a curriculum module. That's it. And you can set up pages that you're supposed to do to finish that curriculum. And so when you click on your name, it actually keeps track of which pieces of that curriculum you've finished. And so you can see that there's some pieces that you haven't done. So in your personal, it'll help you learn. When you want to see what when you click on someone else.
Educational curriculum embedded in this?
Yeah.
Future photography? Yeah.
In fact, if you click on the home page on the lower right corner, there's like the 5 for beginners. There's the 5 different things to learn, like about light, about equipment, so on, about post processing. And so that's one piece of it. And you can at times we've turned it on, at times we've turned it off. But this feature here helps you if you keep track of what pages. Then this feature works really well with the curriculum.
I'm confused. What's stored locally on the E450 versus the fiber channel virtual drives?
The fiber channel virtual drives, what we're going to put on them, we haven't yet put this on, is we're going to put the database files on there. And the reason we're going to put the database files on there versus the HTML files or the photos is that we want to reduce the read-write bottleneck to the database. So if you can get that data quicker and write it quicker, then you can release the locks quicker.
So you can't replicate the data.
Oracle does provide support for distributing the database, though we haven't gone there. We're a little bit reluctant to guinea pig that piece of it. Well, we've heard nobody at ArZigit has done it, and so we don't want to be sort of the guinea pigs and learn the hard way when,
Take a hit for the
Yeah, that's right. That's right. If we had an expert who had done it before, then we'd be all over it. But we just don't want to, we don't want to learn the hard way. It's always better to stand on someone's shoulders in that case. So just getting back to the question about the other thing that people actually use it the most for on Photo.net is they use it to see how active of a user somebody is. So if someone writes a comment and you say, what is this guy, a joker? You can click on his name and you can go see, okay, well, this guy has read a bunch of pages on Photo.net. He's written a lot of B-board comments and he's been around for several years. So I guess this guy, is someone that knows his way around the site. If you click on them, there's really nothing there. All they've done is posted a bunch of classifieds and made a few sarcastic comments. Then you might not take the person so seriously.
So everybody can see everybody else?
Yeah. Well, you have to be a user to do that. You have to be a registered user to see what other people. Then you can see it. Yeah. And it's a different approach. Some people, there's all this collaborative filtering and sort of, there's a bunch of different, Firefly had an approach to, I can figure out what your likes are based on what someone else's likes. I think on Photo.net, what we're thinking is, it was really nice is each user, instead of having users' comments be rated, let each user be rated on their, as to what the community thinks of them in general. They're already doing that implicitly because when you see these conversations going through, you can tell people are clicking on this and seeing, whether someone's a respected member of the community or not. But that doesn't come out as like little stars or something, badges of honor. So, so that's one of the things we're thinking about doing because these photographers, they take their work very seriously, and when they've contributed a lot to the site, they want to be taken seriously on the site, and this helps promote that.
How do you ban users? You said before in some cases you may decide to ban some users.
Well, we ban users whenever they do things like try to spam, whenever they do things.
How do you do
there's
it?
there's some tickle scripts in the ACS that you can. It's called the administration interface. You can click on that, and then it shows you here's all the users, and you can click on a user, and you can say here's all the information about that user, and one of the options is ban or delete. And so you can say ban, and you click on ban, and you type in a reason for why you want to ban them. You click OK, and then you're done.
So if I am the user, I will just register again with a different name, or
yeah, you can come back again with a different name.
Okay, so
and
I just have to keep changing my name.
Yeah, and this is actually an interesting. There's a story about this. A way Philip was able to get rid of a user who was doing that, and what they did, he realized that if you ban someone in a way that tells them they're banned, they're going to get upset and try to come back. So he said, but nobody questions when you come to a site and it gives you like an error or something like that. So what he did is he made it so when that user would come back based on the IP address they were coming from, that they would start getting these server errors all the time. And eventually they got so frustrated with all the server errors that they were getting and not being able to post and make trouble that they just left. And that was even though it had nothing to do with that's the way he ended up essentially banning the person. Didn't know better.
Does it cost money to be a user?
No.
How does the site make money?
We have some co-branded stores. So if you buy through one of our co-branded stores, then we get a cut of the. So that's how you support Photo.net, is by buying through the co-branded stores.
So that's the only.
Well, there's also classified. If you're a volume seller, like if you sell lots of classifieds, you can only sell 10 if you're a regular user, and if you want to sell more than 10 per year, then you need to register as a volume seller, and then we charge you a percentage of the sale. We also have subscriptions. People love the photo critique on Photo.net, and if you upload a photo, people can write comments. You can always go look at those comments, but if you'd like to be emailed anytime a comment is there, we'll charge you like $15 a year for that. And we give you a Photo.net email address also.
Does it pay for it?
Not yet. We're working on it.
So who pays now?
Well, right now it's been we have some angel money that we brought in, but the site itself is being hosted by Ars Digita, and part of our deal there is we do some work for them, some in-kind work, and then they have this hosting for us. So one of the things that we do, for example, is their current demo. If you look at, they're doing a company launch, and their demo is all based on Photo.net. So they took a bunch of our comments, articles, and they're showing in the demo how people go to buy things through learning and through community. So we license that to them for free, is one of the ways that, and that's one of the in-kind things we do to get to stay on their good side and make sure that we can walk in the next day and have a desk. Yes?
kind of the queries and reducing the load on the database, could you not make the database write out HTML pages? So in other words, increase the proportion of static pages, so that if you have, for example, an article with comments and so on, when someone adds a new comment, you go back to the server, and the server writes that as a static HTML page, and all subsequent accesses to that page are static until somebody else makes another comment, and then writes it out as another static page.
Yeah, you could do something like that. Definitely, that's a very interesting. Basically, you're trading off disk space at that point because you want disk space to store all these. You could do that. Another related thing that you could do is cache. Once you create this thing, is cache it and do that for the most frequently used pages if you're worried about disk space. That's a great idea.
Does that cost things like the concurrency protections that the database gives you then?
Well, in this case, even if your consistency, window is, you don't really need a very large, a very fine consistency window, because what's going on there is if somebody writes a comment, right, the worst thing that can happen is, if it's 5 minutes, then 5 minutes later they see it. For our users, they actually like to see things pretty instantaneously. But if you have a lazy cache invalidation algorithm, you can do that, which means that whenever you update the page, whenever you invalidate it when you write something, but then you update the whole page once you actually need to output it.
How many support email messages do you get a day?
Not very many, actually. I mean, we get people will write questions saying, like, I can't log on, and you have the standard response you send back saying, here's how you log on. You just copy and paste that. So you end up getting, of that type of message, that ends up being the bulk of it. And I would say maybe 20 a day, 30 max. Then you have the other type, which is I'm getting server errors and everything, and I used to be able to work this and now I can't. And those tend to be a little bit, we always look at those a little bit more carefully to make sure that nothing weird is going on. But the interesting thing there is about 80% of those end up being something where someone flipped a switch in a firewall and these guys were accessing things at work, or their ISP changed something and now they're having troubles on their side. So there we can't tell their firewall what to do. So we're kind of out of luck in trying to help them. Yes.
I'm curious in the problems that your growth has caused you. You said you've grown by a factor of whatever within the past year. So has that maxed out your RAM and then caused you to go look for the storage network stuff?
Well, it has. It started as that was going on. A lot of bottlenecks started creeping up. So the search was one of them. Search used to take a long time. It could take minutes on our machine, and this was ridiculous. I mean, there's no reason why it should be taking that long when we only had a few 100,000 rows to search.
And that was because of the driver?
That actually was because of the way that it was implemented. The standard ACS implementation for site-wide search. That's what it ended up being. So I ended up spending like a week running around finding like people who were experts in search and getting some bits out of them, and then adapting what they did to Photonet. And I completely rewrote it. And now they're starting to they're going to implement that approach in ACS 4 and also in some of the current sites. But search was a big one. As an example, as we started growing, our load on the machine started going up. And we started seeing a lot of searches backing up, and this was a huge problem for us because when you run out of database handles, nothing can be served anymore. So when it was finally fixed, we noticed that the load on our machine was something like 30, which means there's an average of 30 processes that were backed up, waiting for something, and it immediately dropped down to about 5 or 6. And now it hovers like between 3 to 6, depending on where we are in our traffic peak. So that is an obvious bottleneck, and that was something that as you scale the site, search has to work fast. Mm-hmm.
Because of the driver?
No, that was because of the part of it was the driver, that you couldn't actually tell Oracle what you wanted to get out of it. So I actually had to write some Oracle procedures, because Oracle allows you to write procedures that would actually create HTML and send that stuff back to me. So then I knew exactly what I was getting. I knew it was bounded. And I knew that this extra work wasn't being done. Yes?
How many people work on the site?
There's 4 of us. 4 of us full-time, and Philip will occasionally write some articles and reviews and send those over that we put up. But then we also have a volunteer moderator staff, and it ends up adding up to about a half of a full-time person. There's about 6 of them, and they log on maybe an hour a day or something like that and moderate to make sure the quality stays up. That actually is the hardest part about all this scaling. I mean, I've gone through all this technology piece. The hardest piece of the scaling was not the technology piece, because there you just have the kinds of approaches we learned about to get through that. The hardest part was scaling the community. And what do I mean by that? Well, if you think about why some communities destroy themselves, is because they start off, this really high signal to noise ratio type of group, and there's a lot of cool stuff and everyone kind of knows each other, and then as it grows, all of a sudden all these newbies come in and it smashes the culture, but worse than that, it shoots the quality of everything way down. And this is what happened to the rec.photo types of the Usenet. I mean, Usenet is this scalable, pervasive type of bboard infrastructure, but our users hate it, and they love photo.net. Why? Because the quality of the post is very high. And maintaining that quality over a 10-fold increase in uniques is very difficult. And so we have our moderators, we've worked with them to come up with techniques behind the scenes to make that possible. So one of the things that we do is we have 2 forums. We actually have the moderated forum, and then we have what we call the unarchived forum. And the unarchived forum has a very counterintuitive policy. So the moderated one works as you might imagine. You put a post, it sits somewhere hidden, the moderators decide whether to accept it into the moderated forum or not. If it's not accepted into the moderated forum, it goes to the unarchived forum. The thing about the unarchived forum is any question that you put on there gets deleted after 24 hours. And what happens after 24 hours is the question you posted plus all the answers get put into an email and they get sent back to you. Now, when we first started discussing this, I was actually pretty much against it, because I said 24 hours, people are going to be really mad. How are you going to, get anything? And they insisted that the way they convinced me was, as I suggested alternatives, they said, well, we've tried that on rec.photo and that didn't work. Oh, we tried it on this and that didn't work. So they tried a bunch of different stuff that you might naturally come up with. And they said, this one hasn't been tried, and it has all the right incentives aligned. So for example, if you want your post to be posted in the moderated forum, which stays around forever, then you're going to spend a lot of time crafting a good quality question. Because if it's not a good quality question, if you just kind of throw something out, it's going to get thrown into the unarchived forum. The other thing is that you're going to do a search on the site to make sure that it's been asked, that hasn't been asked before, because if it has been asked before, then it's going to get thrown out and all your time will have been wasted. So all the incentives are aligned if you want longevity of your post for it to be there. Now, the other thing is some people might say, well, this unarchived forum, it sounds like a second-class forum. But guess what? The other thing that happened is that forum has become the most active forum on photo.net. And the reason is just people like to come and shoot the breeze. And they come in and they'll post, like, what do you think about this camera versus that camera? And that's not a question that has it's not going to live, it's not going to, in 5 years, no one's going to care about that as much. So that's the kind of thing you want in an unarchived forum, but that's what people like to do. And as it turns out, this 24 hours has been the right time limit, in the sense that people who post their question, if it's a question that the community is interested in, it typically gets answers within the hour, if not less. So if something lasts more than 24 hours, it's unlikely to get any answer. We've actually allowed you to extend that so that if you don't get any answers to your question after 24 hours, we'll extend the life to 72 hours, just as a concession. But that's, for example, that had a much more dramatic impact on scaling our community than the technology did. With the technology, you just, you figure it out and you just put the sweat in and you do it. This other piece is the non-intuitive piece, where you have to take a risk that you might, screw something up and chase people away.
Is there any provision to get all of this stuff into search engines? So, since all these pages are dynamic, can spiders get through your site? Actually,
they can. If you look at Photo Learn, which is if you type in good camera store into Google, what you get back is a post on photo.net. That's a dynamic page. So they actually have gone through. Google has gone through our bboards. Another set of performance improvements you can have here, Akamai. So if you Akamize any files that don't change often, like our photos or our GIFs, which basically don't change, then you can serve those much more quickly, much more easily, but that costs money. This other one we briefly touched on was replicating the architecture. So the idea here would be there's two levels of replication. One is to say have two E450s here. So then you have these, whenever you need database access, there's two places you can get to it from. Your transaction rate is effectively doubled. But as always is the case with replication, you start getting into nasty consistency issues. The database is something that needs to be consistent. We talked about some ways to do that in class, and Oracle has a bunch of stuff that where they say they can do this, but doing something like this is never trivial. It's not just flipping a switch and all of a sudden it just works. There's a lot of complications that can come into play, most of them being around performance. So that's one thing we haven't done. The other nice thing about this actually is that there's different pieces of the ACS where you want different levels of consistency. And so like you might not care if a B-board posting gets posted, it gets recorded at 1 within a minute of it getting recorded somewhere else, because what's the worst that can happen? Some other user doesn't see it for another minute. However, something like chat, which is based on the database, does matter, because if you're chatting, you actually want to see what other people have written in reasonable real time. So you can actually try to manage the merging or the replication based on an end-to-end argument of what is actually can have looser or stronger consistency constraints. And finally, the thing that they've done already with ACS4 is to go from something like Tickle to something like Java. So you can compile away all this extra layer of interpretation that happens each time someone hits a .tickle page. Okay. Questions? Yes?
Tickle initially rather than like C, something that you could compile.
What's that?
Why use Tickle rather than compile language?
I remember this was like the question in our Wild West session at the beginning. The standard answer that I've heard is that, and it was C at that time. It wasn't going to be. It was between C and Tickle or Perl. The big reason was that Tickle was very easy to learn, very easy to teach. And so Philip wanted people to be able to use the system, and yeah, that's right. And it wasn't a big site back then either. He was just writing these so that his photographer friends could interact. It became big as in, it turned into, that software became the Ars Digitis ACS after a while.
So what's the plan for Photonet? To be profitable?
Yeah. I mean, the good thing is that because it's one of Ars Digita's really good sales and marketing tools. They can go to it and give the statistics that we said. So they actually have a huge incentive to make sure it keeps running. So I mean, worst comes to worst, and our funds dry out, then it'll still keep running, and these co-branded stores will still keep going, and eventually it should build up to a point where it can sustain itself. So it's the fact that we have enough of a user base that people pay it. See, the goals were basically we need to build up the user base to the point where commercial interests will pay attention to us, right? If we had a quarter of the traffic we did, they'd be saying, "You're too small. We don't want to deal with you." So we're at the verge where they're paying attention to us. So then at that point, which was recently, we started creating these partnerships and doing co-branded deals. And so that we're hoping will, balloon up into a revenue stream that will be able to sustain the site.
How many users do you think would be turned off by commercializing?
That's a very good question. That's one of the big pushbacks that we get from people when we ask them for money. Is if you commercialize this thing, you're gonna blow it up. There's actually been several long B-board discussions about that. And the general feel that we have is it depends on the type of commercialism. If you start going in and being all showy and jazzy and throwing banner ups everywhere and like that, that's going to turn off a lot of people. If instead you're a bit more subtle and elegant, which is sort of the style of the site, then users see it more as, okay, well, these guys, nothing's for free. I understand that, and it isn't in my face, and they're not forcing me. I have a choice of merchants to go to. It's not just one that they're trying to shove at me. So I'll do my fair share and do that and buy through these stores instead of buying normally through the normal channels. So that's the approach we've been using. It's been quite successful actually. Today, given the numbers, our conversion rate the conversion rate, which is one of the numbers that people look at very carefully, is the number of people who buy divided by the number of people who click through to the store. So if I click through to Photo Alley, and I buy, then I have a 100% conversion rate. Typical numbers I've heard these days are between 0.5% and 1.5%. And so far, the conversion rates we've had in our stores vary between 2.2 and 2.5%. So that in and of itself is a great marketing tool for Ars Digita, because they say, well, the reason that this is going on is because the learning leads to buying. Right? You learn about something, you see you find what you need, why you need it, and then there's a click there that says buy and support this site, and then you come back when you need to learn more about it, because this is the community that will help you with that. You'll see a lot of, if you want to see all the marketing version of that, you can go to the Ars Digita site, and they have these brochures and all the graphics and stuff. Mm-hmm.
At least with Perl, isn't there some way that I don't know what the mechanism is, but some way to make the script like available in a process so it doesn't have to fire up the interpreter every time to handle each request? Like so it's more similar to like a servlet approach or whatever.
I don't know, actually. I don't know the answer to that, if you can do that.
The interpreter is embedded in AOL server. So it's not...
Oh, so the interpreter doesn't have to fire up every time?
Yeah, it's embedded in. It's one interpreter. It's a multi-threaded interpreter.
So it's just a matter of the interpretation.
That's right. That's
There's
right.
no way to get around that, I guess.
Yeah, unless you can, byte compile or do something like that. All right. Okay. For tomorrow's the big presentations, if you guys have any questions about that, let me know.